So the point of this micro lecture is to talk about the cost and power of electricity. So before the Industrial Revolution, 1700s or before then, most heavy things or most work was done by horses or humans, by animals. But what if we could make machines do the work instead of people or animals? And so an idea that had been around for a long time was the steam engine. The steam engine. And so how that worked is it had hot water. Let me read that. It took hot steam, which was rising. That's basically heat energy. And people would engineer or design some kind of contraption that would take this steam or heat energy and convert it into mechanical energy. And so you get some kind of motion. Right. And so this had been around for a long time. So people say even from the ancient Greeks. But it was more in like the 1700s, the Enlightenment period, all kinds of things going on, that people started working on this idea of the steam engine more and making it more efficient so that would actually do something. And specifically, a huge turning point was in 1778 when James Watt significantly increased the efficiency of the steam engine. And so around this time, due to James Watt's optimization, the steam engine could actually do work and be trustworthy and efficient, right? And so James Watt, being the scientist that he wanted to know how good his steam engine was, and he wanted to actually quantify how good the steam engine was. And so in order to quantify the steam engine, he came up with something called horsepower. Horsepower. He decided to quantify the relationship or the comparison between the power of his steam engine versus the power of a horse. So first he started with the power of a horse. He said, okay, if you have an average horse, that's a pretty ugly looking horse, right? Average horse is going to pull some coal or something. Usually they're using the mine, something heavy. Like my horse is pretty awesome. Okay. Anyway, so he said, okay, so there's horsepower. Someone before him had already invented the idea of a foot-pound. Now, the foot-pound was a unit of energy. And the foot-pound was how much energy it took to raise a pound of coal the height of a foot. So you want to increase it. You want to raise up this coal. And so you have a pound of coal, you pick it up by a foot, and that's 1 foot-pound. And so horsepower is actually related to how many foot-pounds you can carry per minute. And so James Watt went around and measured a lot of horses, and so he said the average horse, working at an average pace, could carry, let me look up this number, 33,000 foot-pounds per minute. So 1 horsepower, that's this new unit that James Watt had created, 1 horsepower equaled 33,000 foot-pounds per minute. It has a speed in there as well. So we're coming to this important idea, thanks to James Watt, called power. And that's actually what's important, because you don't just care about how many foot-pounds you can carry over eternity. You want to know how many foot-pounds a person or a horse can pick up in a day, right? There has to be an extra time in there. So power brought in this idea of foot-pounds, how many pounds you can carry, you can raise by a foot, but also minutes. And so the average horse is 1 horsepower. The average human being at their peak, like their peak running, sprinting, is also going to be about 1 horsepower. But that's only when they're sprinting. 1 horsepower is a horse when it's working at average. Let's see. Probably the most common place that we hear horsepower nowadays is for cars, right? The average car is around 100 horsepower or a little bit more above that. And I keep having trouble spelling horsepower, right? So that nowadays a car is about 100 horsepower. The other thing I looked up was a light bulb. Your average light bulb is actually around 0.1 horsepower. And here I'm going to put as HP for horsepower, right? I'm going to be lazy here because I can't spell horse apparently, and a car is 100 HP, 100 horsepower, and a horse is 100 HP as well. All right, so this is our terms of foot-pounds and horsepowers. So I keep getting close because I'm moving my notes around. All right, and so nowadays, well, you see this is foot, pounds, and minute. Just by looking at foot, you can know scientists nowadays don't really like the term foot. They actually use the metric system. They're using meters and kilometers, and so instead of pounds, we use kilograms. And so instead of using foot-pounds, nowadays, we mostly use watts. Right? So horsepower is still used mostly in cars, but we mostly use watts. For example, light bulb. Light bulb is what? I said 0.1 horsepower. Right? That's the power that the average light bulb uses. 0.1 horsepower. But actually, we prefer watts, and so it's about 100 watts, right? And that's not exactly correct. It's actually more like 76 or something like that, but I'm going to just put it at 100. Right, so our average light bulb is about 100 watts, and we're going to mostly use this W, which is watts, which, yes, is named after James Watt, who I just talked about. All right, so we're going to use watts, and we're going to move to the cost of electricity. We want to get to cost. All right, so cost of electricity. There we go. All right, so the cost of electricity is usually given in electricity rates. Electricity rates. So depending on who you're getting your electricity from, where your power is from, they're going to give you, this is our electricity rate. This is our electricity rate if you live here or there, or whatever. And that is usually in cents per kilowatt hour. Okay. And usually it's about 10 cents per kilowatt hour. So I can even put it in 0.10 per kilowatt hour. I think that's still on the screen. Yeah. All right, so what is a kilowatt hour? The kilowatt hour is a unit of energy. And so energy, I talked about before, one of the units of energy is foot-pound. So that's like the total, misspelled pound, that's fine. So that's the total like pounds that you can move 1 foot, right? There's no time in there at all. That was what they used to use. Nowadays we use a term called joule. That's what scientists like to use. But electricity, we like to use something called kilowatt hour, right? So to convert from energy to power, what do? You got to have some time in there somewhere, right? So energy, I'm going to use E for energy, will equal power times time. Right? I'm going to use another color here. Time, power, energy. That blue's not really showing up, but I think you can see it, right? And then the other thing here is units, right? You got to keep the units consistent. And so I'm not going to try to explain a lot of stuff, but we have kilowatt hour, and so energy, we want a kilowatt hour. Our time is going to be in hours. and our power is in kilowatt. Right? I had previously talked about watts, and here I said kilowatt. So what's the relationship between a kilowatt and a watt? Well, that term kilo stands for 1,000. And I'll put it up here. 1 kilowatt equals 1,000 watts. All right, so I'm going to try to do a little bit of math here. That's our total cost. Let's do a couple of examples. So, for example, I'm going to erase that equation, but don't worry, it'll show up again. And I have my notes right in front of me. All right, so the average American household uses 10,000 kilowatt hours per year. So that's the average American household. American house. Right. The average American, we live pretty comfortable lives, so we're using a ton more electricity than probably 99% of the world. But just saying, the average American household uses 1,000 kilowatt hours. Let's say we have an electricity rate of, is it, on average, or typically it's around 10 cents per kilowatt hour. Right, so your total cost for the year for 1 year equals this 10,000 kilowatt hours, 10,000 kilowatt hours times 0.1 dollars per kilowatt hour. And so we're getting $1,000 per year. Per year. If you can believe it. So the average American household is spending approximately $1,000 per year just on electricity for the whole year. That's a lot. All right, so, but that's, of course, obviously, just adding up a lot of other things. Right, so let's look at just something small. Let's look at our just one light bulb again. Right, so I'm going to leave that up there, a rate of 10 cents per kilowatt hour. I'm going to say, go back to black. Right, so I said a light bulb uses about 0.1 horsepower, but we've forgotten the horsepower, we're doing kilowatts. So a light bulb actually uses around 100 watts. I got to convert that to kilowatts because we always get our electricity rates in kilowatt hours. And so I need to divide that by 1,000 and we get 0.1 kilowatts. Right, so the average light bulb is using 0.1 kilowatts. Right. Let's say we want to know how much it costs to run a light bulb for 1 day. We'll say 1 day. How much money for 1 day? Let's say you want to turn on your light, you leave it on all day. 1 day is 24 hours, right? We got to put this into 24 hours. All right, so our total cost for a day is going to be our power times time. I'm going to use parentheses here. So our power is 0.1 kilowatts. The total time we're talking about is 24 hours. And then we have our rate, which is that 0.1 dollars. And if we multiply all of these, again, if you have between these parentheses, let's see, so our total cost equals, let me simplify this, 0.1 times 24 times 0.1, and we get, that's a dollar sign, 0.24. So it costs about $0.25 per day, $0.25 to turn on your light bulb and just leave your light bulb on all day. So if you don't turn on your lights, in your room, you can count how many light bulbs do you have in your room. And each of them, if you leave it on all day, it's going to cost you $0.25 a day. Or I guess you probably don't pay electricity, but it costs your dorm about $0.25 a day per light bulb that you leave on for all 24 hours, right? If you left the light bulb on for 24 hours over a whole month, that's $7 a month, more than $7 a month per light bulb. So you can see how this adds up, and that's how we eventually get to that approximately $1,000 for that average American home for electricity per year. It all adds up. All right, so this is all about what electricity is, the power and energy, and then the cost of electricity. The next video is going to be about the different sources of electricity, how we actually generate this electricity from different energy sources. And especially I'm going to focus on renewable energy sources, but that's in the next video.